Combinations and permutations test design with Python. It never hurts to have a tool at your disposal that helps you generate interesting sets of values to test. Most problems have multiple variables with a lot of combinations, and sometimes it just makes sense to do some basic combinations and permutations to come up with interesting sets of test data, interesting orders of operations, etc. Now, if I wanted to use combinatorics to take a large, huge set and come up with a small set, I probably would do the pairwise combinatorics that we've already looked at, or Pareto analysis that we've already looked at. But in general, we find that combinations and permutations are pretty handy things. It's something we should always be prepared to do in any level of testing, whether it's unit testing as we're writing the code, or whether it's system testing as we're making sure a product works, or whether it's regression testing. If there's multiple variables with multiple options, there's probably built into that some sort of combinations testing problem. I found that using the tool is handy. Over the years, I've used different tools. I've been a big fan of scripting. In my early days of scripting, I had to use proprietary scripting languages, and then I moved to Unix shell scripting languages, and I learned the Bourne shell, Corn shell, C shell, B shell, all these early shells, and then the more evolved versions of those shells. But that wasn't enough. I had to really go beyond that. I had to learn tools like sed, lex, yak, and my scripts were very hard to understand by anybody who didn't know those tools. So I moved from there into Perl programming. I got pretty good at scripting in Perl, although Perl was syntactically obtuse, but it was really powerful. It got the job done. Then they made Object Perl, which even made it more powerful and more cryptic. It was wonderful. And I moved from Perl to Ruby, mostly because there was a huge readability thing. Ruby scripts became a very readable thing. And today, at the urging of all my students and customers, I'm basically looking a lot at Python. So I find Python has just got so many fantastic resources, and customers of mine are actually using Python to develop complete applications. So even though it's a scripting universe, it's robust and does a fantastic job, highly scalable, great for building applications from scratch. And the libraries that come with Python are just awesome. So what I've been doing is for my combinations and permutations testing for the last couple of years, I've been basically relying on different Python libraries to help me do the job. These libraries are much more syntactically relevant for testing than anything I used to do with Ruby or with Perl. So I think the Python stuff is just graceful for combinations and permutations. And this is something you're going to see a lot of. You're going to see a lot of this in testing. So when you have multiple variables, you might want to explore selections of multiple variables. So what is a combination? So if I have these 10 variables, maybe I'm going to combine 3 of them and see how it works. So I'm going to look for combinations and selections. So choose N from M, that sort of thing. Also, I might, when I have multiple values, look at the orders of them. So this is the permutation. So I have combinations and permutations. Combination selection, permutations, shuffling things around. And these, of course, are things that are natural things for shaking down code. Trying things in different orders and different sequences with different values is a way to sort of exercise an application. And the more variation, the better, as far as I'm concerned. So these tools help me do it. Let me give you an example of permutation. Permutation is pretty simple. Let's say you have an application that has 4 possible operations. Create an object, read an object, update an object, delete an object. And this is your basic CRUD set, right? Create, read, update, delete. So most systems that allow you to manipulate objects have these 4, at least these 4. So let's test these 4 operations, but we don't want to just test them. We want to also try them in all possible orders of operations. So if there's 4 with all possible orders, that would give us 4 factorial choices, right? Which is 4 times 3 times 2 times 1, which is, I believe, 4 times 3 is 12 times 2 is 24. I believe there's 24 different permutations of this. This little script, this actual 5-line Perl script, is enough to do the job. So imagine the library we use, it's called InterTools. It's a beautiful library which it helps with iteration management in Python, and it does a lot of beautiful combinations and permutations type of work. So you start and you give it a list with the options you want. So create, release, update, delete. Then you call InterTools with the permutations method with the list, and what it gives you is in an array perm all of the values. So we look at the values in it and we can print them out and get the following results. So this is the 24 permutations. Granted, this could be done by hand. Probably you could write an Excel macro to do this, but I find it amazingly handy that at any given time I can write just 2 or 3 lines of Python and I get a beautiful list of the permutations that I'm concerned with. So that's raw permutations. What if we, though, take that list and we say, well, the application actually probably has more than those 4 operations. There's probably a create operation, a read operation, an update operation, a delete operation, but there's also probably a save, restore, and a reset. So save, restore, backup, restore, reset to a controlled state. And that's 7 operations, and the 7 factorial now starts getting to be quite a large number. So it might be interesting to say, okay, well, I'm interested in testing every way we can combine 3 of those objects. So every way I can choose 3, I want to test that. So I'm going to just basically say, give me every set of 3, and I'll exercise that. And so that can be done, again, with the same library. This is all with the InterTools library, where we start with a list. So this is the 7 operations: create, read, update, delete, save, restore, reset. And then we basically say, okay, let's use the InterTools library. Let's go through the combinations method. And we're telling it to choose all the combinations of 3. And we put that in our list, and bing, bang, boom, you get out the set. And there's basically 35 combinations of 3. So that's 7 choose 3 without replacement. That gives you 35 combinations. And so by testing those 35, you might build a certain confidence that you can do any 3 operations in any order. This is sort of probably a reasonably harsh test for that application. That's a lot less tests than 7 factorial. Now, so we try, if we get all that sets of 3, what if we want to try now for every set of 3, every permutation of the set of 3? So we've chosen 3. Now, if I create, read, update, I want all the permutations. So I want create first, read first, update first, and then create second, read second, update second, and etc. So I want all the permutations of 3. So that's 6 permutations for each. With InterTools, this is graceful again. We do a little nesting here. So the first one is to get the combinations of 3, and then for each member of the combinations list, we want to do the permutations of it. And that gives us basically a set of quite a lot of test cases, 210 test cases, which gives us every permutation of a selection of 3. Probably that's a bit too much, so you can experiment and try to do fewer sets or fewer variations. What if you want multiple variable variations? So imagine you have multiple variables you're going to be manipulating. Let's say we have 3 variables: transaction type, the location, and the customer. So it's the transaction is create, read, update, delete. The location is domestic or international, and the customer is a newer existing customer. So we want to be able to try all possible variations of each, which would mean that we want to have 3 times 2 times 2, which is 6 times 2 is 12 different tests, if I'm not mistaken. To build the set, you just create the 3 lists for each of the lists: the transaction, location, and customer. And then you basically use the product operation in the InterTools library, and it will generate all of the possible combinations of 3. There's 16 variations of them. That's pretty graceful to come up with that. What if we have 4 transactions and we want to try all combinations of 3 of them, but we want to allow repeating the same transactions? So in other words, we might say, let's do a create, read, or an update, read, or an update, delete. So we want to have repetitions allowed, and this is realistic. In the real world, people do things like that. So the way to do this is say get combinations with replacement. So this is basically combinations with replacement. and we grab our list. That's the 4 options. We're going to do the combinations 3 with replacement, and that's the raw list. So this is with repetitions. So if you take a look at this, there's 20 combinations here, and you take everyone, create, 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 read, create, update. So it's like a traversing all the combinations, create, delete, create, read, create, read, update, etc. And we go through 20 different combinations of them with repetition is in there. So you'll have delete, 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 for example, is the last one. And then there's some other things you might want to do. For example, this is a beautiful case. This really happens in software. You have an installation, and many installations have configuration options. Many installations have many configuration options. And which set do you choose? Well, it works out if you study installation of software, especially consumer software, and Microsoft did a lot of work in this area, so I sort of learned this sort of trick of the trade from a lot of testers at Microsoft. They said, well, you know what most people do? They take the default options for almost everything, and they vary a couple of things. So it would be interesting to say, well, if there's a lot of options, why don't we design a series of tests which basically uses the default option for most of them, but chooses a couple that they're going to vary? So what if we try this? What if we try to vary 2 options in each trial, and we have 10 to choose from? So here we can look at this, and we can say, okay, let's make our list. So there's the 10 options to choose from, and then we're going to pick 2, and that will give us 45 trials. So these are so everything that's not listed here is default, and these are the 2 we vary. So in 45 tests, we may have very thoroughly tested all the practical installer combinations for the system. Now, we might want to randomly choose options in each trial. So if we want to basically choose 2 randomly in each trial, then we have the notion of taking the same list with the same permutations, and then we shuffle each permutation to randomize it a bit. So that gives us 45 random ones. And we can then combine random combinations, permutations with the intertools library in Python. And there's also tons of other libraries in Python that can be used to help us do all sorts of generation of interesting combinations, permutations, and subsets, including random subsets of the variables and the values being tested. So thank you very much.